continue. Next speaker is, can we just show? It's Ignacio Antón. He's from the Polytechnical University of Madrid and their Energy Institute, and he's a professor there and head of department, and speaks on behalf of the HiPERION project. And his title is Challenges in the Power Rating and Design Qualification of Tracking Integrated Hybrid Modules. Ignacio, the floor is yours.
Okay, hello. So can you see my screen?
Yes, very well.
Okay. So I will continue with the talk of from Florian, and I will address one very important thing needed for the marketing of any new PV technology. As you can imagine from this last talk, the challenges that arise with this new technology are huge in terms of standardization and characterization of this approach. So this is the content of my talk. I will start with an introduction about international standards and the priority for the marketing of a novel PV technology. I will review the distinct characteristics of the hybrid module, and then I will enter in the core of this talk. First, the design qualification, and then the power rating of hybrid CPP PV modules. The International Electrotechnical Commission is a global non-profit organization which is devoted to the standardization in electronic and electrical fields. It is organized in technical committees and subcommittees, and the TC82 is the one that addresses solar photovoltaic energy systems. Standards provide guidelines and requirements that are then used to design, to manufacture, to install, test, certify, maintain, and repair electrical and electronic devices and systems. They are the result of a global consensus among many technical experts who are delegated by the countries to participate in the ISE. International standards are essential to provide confidence in the market, from component suppliers and product manufacturers to final users, financial actors, and insurance companies. In this regard, when a new standard is developed, particularly when it is created from scratch, one must have in mind that this is a very long process that may take even several years. So it is very, very important to use existing norms as a starting point to accelerate the process. There is a bunch of PV standards developed in the last decades, most of them revised several times. TC82 has currently more than 160 publications that covers qualification, performance, characterization, evaluation methods, safety, rating, monitoring, requirements for specific sensors, equipment, application or claimants, transportation, shipping, etc. And of course, all of them are relevant, but some are prominent and essential for the marketing of a PV product. A new technology may require the adaptation of many of the existing standards, a huge work that must be prioritized. Particularly attention must be paid to two aspects. The first is the design qualification and the type approval, the standard that defines the minimum requirements for long-term operation in general open-air climates. And the second, and the second is the power rating of a PV module, which determines the nameplate power at fair and comparable conditions among PV technologies. The hybrid CPP PV module has unique characteristics. The first is that it introduced two different PV technologies, one based on concentrated light and three-phase multi-junction solar cell for the electrical conversion of the DNI. As any other high concentrated technology requires some tracking. The main difference here is that the tracking is embedded and the module itself is totally static and can be installed in a fixed structure as shown in the picture. The second technology consists of conventional silicon cells integrated in the backplane for the conversion of the diffuse light. although it can also benefit from DNI spillage in the model or even convert the whole DNI for angles of incidence beyond the limits of the tracking system at early and late hours of the day. But certainly, the most distinct characteristic is the internal tracking, which include mechanical parts, actuators, sensor, and control electronics. A specific failure mechanism non-existing in conventional CPV or PV models must be consequently considered and addressed in the norms. Let's discuss first about the qualification of a hybrid CPV-PV model. The PV market relies on design qualification, which requires less time and cost than reliability standards. PV models are designed to last decades, and practical acceleration factors achievable in a test have a limit. So reliability will require very long and expensive tests. On the contrary, the completion of all the tests involved in a qualification standard can be carried out in weeks. Past criteria require no failure and a performance degradation typically below a threshold in the model performance. One question arises here. Are the existing qualification standards for PV models applicable to the hybrid? If not, which is the best approach to get an applicable one in the short term? ISC 61215 is the norm for the design qualification and type approval of conventional PV models, which follows a very standard design. The hybrid concept is totally out of the scope of this normative. On the contrary, ISC 62108 was not conceived for a homogeneous product, but to cover a wide variety of types and architectures of CPV models and systems, and provides a better starting point for the hybrid model. There are two distinct characteristics that make 62108 preferable. The first is that it enables lower maximum temperature, 65 degrees instead of 85, in the accelerated test at the expense of a longer test duration. This is a necessary condition for some materials used in the manufacturing of CPV optics. The second is that test procedures relies on side-by-side IV measurement to identify power degradation of a test sample by comparing its relative power to a reference and identical sample. IV testing can then be carried out outdoors, avoiding the need of a non-existing solar simulator, which is particularly interesting for hybrid CPV-PV models. One of the challenges of the HiPERION project is the development of this simulator. Side-by-side characterization is particularly suited for the hybrid concept, with separate terminals for the CPV and PV parts. However, an important challenge must be addressed: the condition for the angles of incidence during the test and the side-by-side characterization. In a conventional CPV models, the angle of incidence is always close to zero, since the model is pointed to the sun in an external two-axis tracking. Here, this condition will be also possible, but it is not the only one, since the hybrid model is designed to work in a wide range of angles of incidence. Special attention must be paid to the reference model used for the side-by-side comparison. It cannot be presumed here that the correct performance of the reference, an optimum alignment of its internal tracking must be assured, and the uncertainty associated to this issue must be determined. The embedded tracking and its components, mechanical parts, sensors, actuators, is one of the specific aspects that have to be addressed. Although there exists a specific norm for the qualification of PV trackers, the hybrid model is totally out of the scope of this standard. The existence of the embedded tracking introduced a new failure mechanism that are not addressed in the qualification norms of PV models. The tracking is necessary for the proper operation of the model, so all its components should take part in the sequences for the qualification of the model. A post-stress correct functioning of the internal tracking will be a necessary condition for the pass criteria, but may not be sufficient for the qualification of this system. Other aspect to be considered is some of the components of the tracking could be replaceable. So there is an open question here about the inclusion or not of a specific additional test in the qualification of the model to address the specific failure mechanism associated to the embedded tracking, or rely this issue on a separate normative. One of the objectives of the HiPERION project is to clarify if an additional requirement for the qualification of the mechanical actuators is really necessary, or on the contrary, the current test sequences are sufficient. Let's discuss now about the power rating of hybrid models. A major aspect to be addressed is the lack of reference conditions for the diffuse light. Let's review the reference condition for the power rating of models. Standard test conditions are defined for flat models with AM15G spectrum and an irradiance of 1,000 watts per square meter. For the case of CPV, two sets of conditions are defined. The models are rated at concentrator standard operating conditions with AM15D spectrum and 900 watts per square meter, and then scale up to concentrator standard test conditions at 1,000 watts per square meter. A fair condition for hybrid models to be comparable to flat plates will be a DNI of a 900 watts per square meters and AM15D spectrum, plus a diffuse of 100 watts per square meters and an AM15G minus 15D as reference spectral condition. A draft procedure has already been defined and published by Schoenhofer with a general scope beyond HIPERION module, considering the optional integration of bifacial synchronous cells and not only internal but also external tracking. The proposed procedure to rate the power output of a hybrid CPV-PV module is only valid in a 4-terminal configuration. This means that the IV characteristic of the concentrator and flat plate PV cells should be measured independently of each other. The rated power output of a hybrid CPV-PV module will be the sum of the independently rated CPV and flat plate PV arrays. The schematic shows the flow chart of the rating procedure proposed. The color coding represents which part of the procedure are originated from which IEC standard. It is mostly based on already existing IEC standard for the CPV in red, flat plate PV in blue, and bifacial PV in purple. However, some of these IEC standards in greens need to be adapted as necessary to account for the particular features of the hybrid CPV-PV technology. The procedure consists of 4 main steps labeled from A to D. The first step, A, is the measuring of outdoor IV curves together with ambient conditions. Then filtering for the standard conditions is applied in B. Stage C consists of the translation of PV and CPV power output to reference conditions. And finally, the power output of PV and CPV parts are combined in D. Instruments, procedure, measuring conditions, translation equation, all has already been defined and tested with a hybrid model, and in this case without embedded tracking. Next step will be the application to HIPERION models and comparison of results between laboratories. A new proposal, the first stage in the development of an IEC standard, has already been created within the Working Group 7 of the Technical Committee 82 in the IEC. So I will conclude stating that the development of an international standard is a long process, so it be based on existing documents to reduce the development time. Being all relevant, qualification of the design and power rating are the most necessary for the marketing of a new PV technology. Hybrid CPV models require some amendments, but existing standards are an excellent starting point. For the design qualification, specific research is necessary to determine failure mechanisms and appropriate tests to address them. For the power rating, the needed consensus can only be achieved if fair conditions among PV technologies are proposed. I would like to thank all the partners involved in the HIPERION project for this really nice and challenging project. Thanks for your attention.
Thanks, Ignacio, for these insights. We are running a little bit late. I would also here refer to the chat for any questions. Thanks so much.